All right, we're recording. The test is tomorrow, right? The test is tomorrow. It's in class. It's our second in-class test in like a year and a half, 2 years. And remember, the worksheet will be due tomorrow by 9 a.m. The notes will be due tomorrow by 9 a.m. And when you're doing your final preparations, remember you can always go to Corpy's World or the link in Canvas. Click on Precal Matters or go to the link in Canvas and you click on your old tests right there. And look at there, 1.1 to 2.1. And I'm frozen. The story of my life. Yeah, there you go. Always frozen. Yes, yeah. So if you look right there, 1.1 to 2.1. There's two of them, 2013, 2019. The key is posted. Those are designed to be 50 minutes. The only thing is these cover all of 2.1, right? So if you see a question that deals with like holes or vertical asymptotes, I don't think this one does. I don't think this one has holes or vertical asymptotes. It's a little squirrely right there, but yeah. So that one looks good, except for the squirreliness. If you look at the key, let's look at the key. The key probably doesn't have, yeah, the key. So if there's a question on what it's supposed to actually look like, the key has it. So this is actually a good test from start to finish, because there's nothing on here that deal with holes or vertical asymptotes. Seven multiple choice questions again, and you've got one free response that's worth 11 checks this time. Okay, 18 total checks. So you could try that. Give yourself 50 minutes. And then the 2019 exam, we'll just pull up the key here. This is the more recent of the two, right? And this one looks good so far. Yeah, so far so good. Now, number 6, okay? See how number 6 says which of the following is true, and it talks about a hole in vertical asymptote? You won't have that type of question on the test tomorrow, okay? I'll replace it with another domain question. But again, 7 multiple choice. And the free response looks good, right? So everything on this one also looks good except for question 6, right? Oh crap, what did I do? And 7? Oop, sorry. Oh no. 1.1 to 2.1. Yeah. Did you say question 7 looked bad too? Maybe. Oh, yep, sure does. How about that? Very good. Boom. So, boom. Yeah, nice job. Good eyes. Good eyes there, Cole. Yeah. So, anything that says holes or vertical asymptotes, don't worry about. But it's still another good resource, right? Yeah, I like tabs, right? Okay. So I get that out of the way in case we run out of time. Now, here we go. Example 7. Find the domain of each of the following, right? We don't have time to mess around today. So, is the numerator of any concern to us if we're looking just for the domain? No, not the domain. But the denominator, we have a square root with a variable underneath it, and of course we have a denominator. So we'll treat those as 2 separate cases. Yeah. Number 1, we take the entire radicand and we say it's greater than or equal to 0, right? Sock. Let's put up the entire denominator. The entire denominator, that +1 is outside, cannot be 0, okay? So there's sock. So we set it up. On a free response question, that's going to be check, right? Sock means check in this case. Check. Let me make sure I've got, okay, well, good. So far, so good? Now, look at number 1. Number 1, is that linear? Can we solve it algebraically? Yes, indeed we can. So we'll just add 2 to both sides. We get x is greater than or equal to 2, and we check it. Right? All we're looking for is, does it give us a positive under the radical? So a number bigger than 2, like 3 should work. 3 minus 2 is positive 1. Yep. A number that's not bigger than 2, like 1, should not work. 1 minus 2 is negative. Good. Boom. Got it. All right. Now, this part is different because when we've seen radicals in the denominator up to now, they've been all by them lonesome self, right? They haven't had like another term. The entire denominator has been just the radical. But we have a +1. So to solve the radical equation, we have to isolate the radical term. And it's not isolated. It has the +1. So our first step is to bring the 1 across, and now becomes -1. All right? Now I'm going to copy this, copy, paste it, because our next step then, now that it's isolated, is to square both sides. Square, square. And that should raise a red flag, yes? A big red flag, right? Or ring a red bell, right? Or a copper brass bell. It's copper, actually. It's brass, actually. Yeah, it's brass. It's yellowish. We get x minus 2 on this side, and then -1 squared is 1. Yeah, yeah? And now we add 2 to both sides, and we get xk equals 3. Now, is 3 greater than 2? Yeah, so we would need to step over it if it does, in fact, cause a 0 in the denominator. That's what we need to check, okay? How do we check? We plug it back into here and see if it actually causes a 0. So let's go ahead and check. I'm going to check. I'm running it. Let's check right here. Check. We get the square root of, plug it a 3, we get 3 minus 2 plus 1. The question is, does it equal 0? I'm putting a little question mark over the equal sign. Well, let's see. 3 minus 2 is 1. I get the square root of 1 plus 1. Does that equal 0? 1 plus 1. Does that equal 0? Notice the suspense. We're going line by line. Does 2 equal 0? No. So what does that mean? It means that 3 is not extraneous, or it is extraneous. Which one? Yeah, it is extraneous, right? Now, at this point, because we're using not equal, I don't really care if you tell me is it extraneous or not. The bottom line is, right? Bottom line is we're trying to find values that cause a 0 in the denominator and toss them out of the domain. So here's the question I'm asking. Does 3 actually cause a 0 in the denominator? No, it doesn't. So do we need to cast him out? No, okay? So the domain of f is just going to be the set of all x such that x is greater than or equal to 2. Or in interval notation, d sub f is x epsilon, beefy bracket 2 to infinity. That's what we're looking for. It turns out that it is extraneous. Yes? You plug in the 3 to this right here, right? You're basically just trying to see, does it actually make the denominator 0? If you keep that in mind, then you'll be like, well, let me try it. Now, if you don't want to plug it into there, you can plug it back into here. You're just plugging it back into the entire denominator. Right, right. If you're going back to what I said up here about extraneous solutions, wherever I think I might have inserted that page. Yeah, it's gone. Let me just do it again. Right. If we're looking for, this solution here, and we squared it, what we found is this solution. It's not an original solution. And because it's a square root, it doesn't even have a solution. So this just kind of shows you how we can get an extra solution. But in this case, there is no solution, right? Now, you could probably spot that, with a keen eye, you could probably spot that right away. Is it possible to take a square root of a number and multiply it by +1, add a number to it, and get 0? No, because when you take the positive square root, and by positive, I mean there's an implied +1 out front. When you take the square root of a number, it's got to be positive or 0. And there's nothing out front that's going to make it negative. So a positive number, when you add 1 to it, is never going to be 0. It's only going to get bigger. Okay, or you can look at it on this second green line. Is it possible to take the square root of a number and get a negative? No, okay? But when in doubt, work it all the way through and then check, right? Check for extraneous. Got it? Okay, let's look at letter Q then on part B. Kind of a similar problem. What's up, numerator? Hi. We have a square root and we have a denominator. So let's put our socks on. Number 1, x plus 5, the radicand has to be greater than or equal to 0. Second sock, the entire denominator can't be 0. The entire thing. Now this inequality is easy, right? X has to be greater than or equal to -5. Let's quickly check. Something that's bigger than -5, like -3, should work. -3 plus 5 is +2. That's good. And again, when we check this, we're only plugging it into the radicand. We're trying to see if it gives us a positive. Something that's not bigger than -5, like -6, should not work. -6 plus 5 is negative. Good. Now, over here, for the not equal 0, I have to isolate the radical term first. So I have to add a 2 to both sides. Now I'll square both sides. And again, I'm going to show that as a separate step. I square both sides. And then that red flag goes up, right? Got to check for extraneous. So now we get x plus 5 cannot equal 4. And x cannot equal -5 plus 4 is -1. Don't just say that x can equal 0. Again, I emphasize that because a lot of students always want to just say x can't be 0. Well, that's not true. What can't be 0 every single time? The denominator, right? But x itself as an input could be 0. When in doubt, you can always plug a number in to see if it works. And when I say when in doubt, plug it into the entire function. What is q of 0? Well, you plug it in the top, you get 11. Plug it into the bottom, you get the square root of 5 minus 2. Is that a number? Is that a real number? Yeah, so 0 works. It gives you an output, okay? Now, here we're saying x can't be -1. Does -1, in fact, cause a 0? Well, let's plug it back in. I'll plug it into this version here. I'm going to check off to the side up here. I get the square root of -1 plus 5 minus 2. And you don't even have to you don't have to do this, equals 0 question mark. You can just evaluate it, right? What is -1 plus 5? 4. What's the square root of 4? 2. What's 2 minus 2? 0. Ah! Does it cause a 0? It does. So it's not extraneous. For what it's worth, it's not extraneous. It does cause a 0. Do we need to step over it? Yes. Now, going back to what I said also, we don't want to doubly exclude anything. We don't. Is -1 bigger than -5? Yes. So we do need to step over it. So here we go. D sub q is the set of all x such that x is greater than or equal to -5, comma, don't use -1. Or in interval notation, which you could choose on the free response, which you want to use, x epsilon, -5 with a bracket, comma, -1, parentheses, step over it, and then go to infinity. Okay? So those two types of problems where the denominator has a radical, but it's not the entire denominator. There's another term out there that helps it. You got to be careful. Notice on this first one, if it were just x minus 2 under a radical in the bottom and there was no +1, 2 would not be in the domain, right? Because 2 minus 2 is 0 and the square root of 0 is 0. But 2 actually works now because 2 minus 2 is 0, the square root of 0 is 0, and 0 plus 1 is not 0. Yeah, okay? All right, any questions on those types? There's practice problems like that on the worksheet. All right, I'm going to, let's jump down here. Okay, there's a lot of 4s in this one. It says to verify in the calculator. We're not gonna have time for that. We don't need to. Do we have a denominator in this one? No. There will be one on the free response like this, guaranteed. So here's all we have to do. We just put on one sock, right? X squared minus 4 has to be greater than or equal to 0. Now, luckily for us, we practice this skill in isolation. So at this point, when we get to it in terms of domain type question, there's no obstacle to getting the right answer. We have set up a quadratic inequality. Can we solve that algebraically? No, it's not linear. So I taught you to solve it graphically, yeah? So that's what we do. let's go ahead and sketch the graph of x squared minus 4. I'm only going to give you a quadratic inequality. I'm not going to give you like a cubic inequality or have you set up a cubic inequality. Quadratics are easy, right? They're parabolas. They either open up or down. Now, we know what this one looks like. It's just our graph of x squared, and the minus 4 does what to it? Moves it down 4. So the vertex is at -4, and it looks like this, and it looks like that. I want to know where it's greater than or equal to 0. Well, remember, y equals 0 is the x-axis. So it's greater than or equal to 0 when it's above the x-axis. I need to know these values here. It's always going to come down to what are the x-intercepts. You could probably look at x squared minus 4 and tell me what the x-intercepts are, right? No? Okay, all right. Okay, maybe you can't. So let's go ahead and find the x-intercepts. You can factor this as a difference of squares. And as long as it's still equivalent to x squared minus 4, you could still have it greater than or equal to 0. But don't do this. This is a big no-no, okay? Don't do this. Don't then say that x minus 2 is greater than or equal to 0 or x plus 2 is greater than or equal to 0. That doesn't always work. If you do that, you're going to lose points, probably more than one, because that's a no-no, not just a no, all right? Now, what's the point then of factoring it if we can't say they're both greater than or equal to 0? Well, when it's factored, we could spot the roots real quickly, right? What are the two values of x that make these two 0? 2 and -2. Yeah. So this one must be -2, and this one must be 2. So you can still factor it, keep the inequality. If you don't want to do that, then come off to the side and say this. You could say x squared minus 4 equals 0. Okay, if you want. And this is basically just to find the zeros or the roots. So then you could say x minus 2, x plus 2 equals 0. And then if you want, you could say x minus 2 equals 0 or x plus 2 equals 0. And then you get x equals 2 or x equals -2. I don't care how you find the roots, as long as you're not lying, as long as you're not doing anything illicit or illegal. All right, so now it's going to come down to, and as you know from a quadratic inequality, it's either going to come down to the interval that is outside the x-intercepts, to the left and right, two disjoint intervals, it would be an OR case, or it's going to be the connected interval, the AND case, that falls between the x-intercepts. It all comes down to what our inequality says. I want it to be greater than or equal to 0. The y values are greater than or equal to 0. Where? Outside or between? Outside, right? So if you're going to sketch that on the x-axis, it would look like this. Equal to would be on, and then we're going to shade to the right, and we're going to shade to the left. Right? Any value outside on the x-axis is going to generate a y value that's above. Okay, so now that I have my interval, I'll go ahead and answer the question. By the way, notice that this graph is not the graph of p of x. This is just the graph of x squared minus 4. It's not the graph of our function, but it's all we need to find the domain. So the domain of p will be the set of all x such that x is less than or equal to -2, or x is greater than or equal to +2. We've solved quadratic inequalities already this year. Or if you like the interval notation, you'll say x epsilon, -∞ up to -2 with the beefy bracket, union beefy bracket 2 to infinity. Need some water, Aiden? No? Okay. Now, because you're setting up your inequality yourself from the radicand, it's always going to be greater than or equal to 0, right? Always. Which means we're always going to be looking to see where our graph is above the x-axis. So the only time it's going to be between the x-intercepts instead of outside of is if your parabola had opened downward. right? If your parabola would have opened downward, now notice it's positive between them, okay? You will have a free response question where you're setting up a quadratic inequality. You're going to get a check for that. You're going to get a check for this. And of course, you're going to get a check for the right answer. That's a 3-check problem right there. Y'all can handle that tomorrow, right? Absolutely. That's equivalent to like 3 multiple choice questions on the front. My gosh, that's pretty cool. All right, any comments or questions on this one? Okay, that's close. I want you now on your own to do M. Very, very similar, okay? On your marks, get set, go. Let me pause the recording. So on D, we got M of X, 4 times the square root of 4 minus X squared minus 4. Still a lot of 4s, but no denominators, right? But we do have a square root. If this were a cube root, by the way, the domain would be all real numbers, wouldn't it? Because there's no denominator, and cube roots of 0 and negatives are okay. Square roots of 0 are also okay, but not negatives. So because there's no negatives allowed under the radical, we say that the radicand has to be 0 or bigger. Now we have a quadratic inequality. We can't solve it algebraically. We got to solve it graphically. We know this is a parabola. It's x squared. The leading coefficient is negative, so we know it opens what? Down. Now, there's several ways to graph this. I'll do it several ways. If you want to, you could actually graph it by finding the zeros by factoring. And because this is a difference of squares, you could factor it right away as 2 minus x, 2 plus x, right? Greater than or equal to 0. And now if you look at that, again, don't set them both greater than 0, but you could then say that your roots, colon, this is how you can do it. Your roots are x equals plus or minus 2, right? Those are the 2 values of x that make it 0. Or you could do this. You can factor out the negative first, and then that becomes x squared minus 4, and it's still greater than or equal to 0. And now that's x minus 2, x plus 2. Remember, if you ever have a negative leading coefficient, in general, it's easier to factor once your zeros are out. Now, you don't want to say x equals plus or minus 2 like that right below this version, because if you do that, you're basically telling me that these are the only 2 solutions to this inequality. And it's not. There's a lot of solutions. So that's why you would need to put something like roots colon or x-intercept colon or something like that. It kind of labels what you're doing. Or you could actually go off to the side and say y equals 4 minus x squared. Now you can set it equal to 0, and now you can solve however you want by factoring it like we did up above, or now you can extract square roots and say x equals plus or minus 2. And then you wouldn't need to label it as roots because we know it's equal to 0, okay? So once we have the roots in any number of those ways, now we can sketch the graph, because you will have to sketch the graph. The roots, let's see, negative 2, positive 2. And for what it's worth, we know that if you want to write this like this, negative x squared plus 4, we know that it's up here at 4. A lot of y'all had that shown. And now it opens downward like that and like that. That's good enough. And now we return to the inequality. For what values of x is it still greater than or equal to 0? That's on or above the x-axis. Well, it's above the x-axis now in between the x-intercepts. So if you were to shade the solution, negative 2 and positive 2 work because the square root of 0 is fine as long as it's not in the denominator. And now we're going to shade everything in between. Okay? So on a test tomorrow, this would give a check for the setup. I'm sorry, not that. This for the setup. This for the graph, and now for the solution. When you write your solution for the AND case, make sure you write it as a connected interval. It's going to be D sub m is the set of all x such that And here's the easiest way to do it. When it's an and case, -2 is on the left, +2 is on the right, and all of your solutions x fall in the interior. So you see how physically x is written between the small number -2 on the left and the big number on the right? This is your compound inequality, and it's reserved for the and case exclusively. You'd never write an or case with a compound inequality, right? And it's either going to be less than or equal to. So you could read this from left to right. -2 is less than or equal to x is less than or equal to 2. Do your math homework. Is it due tomorrow, the worksheet? No, because there's questions on there about vertical asymptotes and holes that we haven't gotten to. So we're not going to turn it in, okay? But you still need to do enough of it. It's better to read it, though, from the inside out. X is greater than or equal to -2 and less than or equal to +2. Any number that falls in this interval is simultaneously bigger than -2 and less than or equal to 2 at the same time. That's why it's an and case. Close bracket. The other way to do it is an interval notation, right? X epsilon, beefy bracket -2, comma, beefy bracket 2. Either one of those. And if you're unsure whether you have the right interval, like I don't know if it's supposed to be between or outside of, let's check. Pick a number between -2 and 2 that we're claiming will work. 1. 4 minus 1 squared is 4 minus 1. That's +3. The square root of +3 is going to work. Yeah. Pick a number that will not work according to your interval, like 3. 3 should not work. 3 squared is 9. 4 minus 9 is negative. Woo, doesn't work. You're always allowed to check your work, okay? So there's your answer. Okay, let's jump down here and do a bonus question. Bonus question. We'll call it 7D part II. We have 10 minutes left in class. We already know what the test is going to look like, right? There's 2 practice tests online from old years, so we can work right up to the bell. You want to work this together or give you a shot? Give you a shot. That's what I like to hear. All right, I'm going to give you, this might be our last one if I give you a shot, but it's worth it. I'll give you like 4 minutes, okay? 4 minutes. Maybe even 3. Okay, so again, we have a variable in the denominator and under a square root, so at risk of doing both. So we'll say x squared plus 2x minus 15 is greater than or equal to 0. And call that the first one. And now the second one, the entire thing cannot be 0. And notice this one is just the radical on the bottom. There's not that extra term. We know this is a parabola that opens up. Positive x squared. If you want to factor it in place, x plus 5x minus 3, that's fine. From there, we'll say the roots, or the zeros, or the x-intercepts, are x equals -5 and x equals 3. Do not, again, do not set each factor greater than or equal to 0, and do not just directly underneath there put x equals, because that's not the solution to the inequality. Those are just the x-intercepts. So write roots, write zeros, write x-intercepts. That's something different. And now we'll sketch the graph using that information. -5, draw your x-intercepts first. Here's -5, there's 3, something like that. And now the parabola opens, we said what? Up? Up, yeah. So again, it doesn't need to be super fancy. It just needs to be the right x-intercepts and opening up versus opening down correctly. Greater than or equal to 0. Again, because you're setting up the inequality from a radical, it's always going to be greater than or equal to 0. So you're always going to be looking for where it's above. And again, in this case, it's outside the x-intercepts. So we'll include 3, and we'll go to the right, and we'll include -5, and we'll go to the left. Now, informally, because there's another part, I know that x has to be less than or equal to -5/5, or x is greater than or equal to 3. This is your disjoint case. This is the OR case. But we're not done. We need to check the other part. When we square both sides, the radical is already isolated. It goes away. We'll check our solutions. And notice, oh, I know what this is. Because this is an equation or a non-equation, I can actually do this. I can go all the way to the end. It's not an inequality. Now, we know these are going to work. If you plug them back in, you are going to get a 0. So again, what's the easiest way to eliminate -5 and 3? Take off the equal sign on the inequality. Good. So if we combine the results now without being mean, the domain of W is the set of all x such that x is strictly less than -5 or x is strictly greater than 3. We don't want to divide by 0. Square root of 0 is still okay, but in this case, it puts a 0 in the denominator. Or x epsilon, -infinity to -5 parenthesis, union 3 to infinity. Okay? Now, again, if you're a savvy, astute student, and I give you one like this, you could just say x squared plus 2x minus 15 is strictly greater than 0. You would get both checks for that. But again, if you don't know when that works, when it doesn't, don't do that, because it won't work when you have a helper term in the bottom, like we did on example 7a and 7b, okay? So you're always welcome to just do it as 2 separate problems and combine your result, all right? I'll be here during B lunch. I have a class during advisory that I teach, so I can't work during advisory. I have 7th period conference if you can get away. I have a meeting after school today in room 629. If you need to come see me in room 629, I could probably step out and help you. Otherwise, I'll be here in the morning, all right? Make sure you turn your worksheet and your notes in by 9 o'clock tomorrow. You can turn in your notes. Oh, I'm sorry. Don't be, yeah, I'm on autopilot. Don't turn them in by 9 o'clock. Don't. Don't turn in your notes. Don't turn in your worksheet. You want to make sure you understand your notes. You want to make sure you understand all the problems in the worksheet that don't have holes or VAs. And work those 2 practice tests. I think you'll be surprised if you haven't done that yet. Work them, check your results, get your questions answered before the test tomorrow, and you'll feel a lot more confident going into tomorrow's test, right? Yeah. Either one. You can do both, whatever's up to you. Yeah, yeah. All right. Really, if you're prepared by working before the test comes down to keeping your amygdala calm, keeping the reptilian hindbrain at bay so that you can engage your cerebral cortex to do well. All right. Have a super fantastic, awesome, wonderful day.